In this video, we are going to talk about why you should take an astronomy course, especially if you are a teacher who is preparing to teach secondary education. Astronomy connects to your everyday life, and it's important for you to see the connections in your life so that then when you go to teach your students, you could share those with them as well. So for kids, it's interesting to know that there is connections to iPhones, film, GPSs, defense satellites, MRI technology, and many of the investigations that have led to inventions and applications can be traced all the way back to astronomical roots. So as a secondary teacher, we could use astronomy to enrich our curriculum. So we know that astronomy is the scientific study of celestial objects such as stars, planets, comets, galaxies, phenomena, anything that really is going to originate outside the Earth's atmosphere. So we could take the information that we learn in astronomy and then we could connect it to the other disciplines that you would teach in high school, so physics, biology, chemistry, and earth science, and figure out ways that we could teach the concepts in those other disciplines through astronomy. Okay, let's, for example, think about physics. In a physics course, sometimes you can incorporate, these are three just examples that you can incorporate. Let's say a black hole. So we remember that black hole is a region of space where the gravity is so strong that no particles or even electromagnetic radiation can escape from it. That's something that you could talk about. Kids often are interested in black holes, so that's pretty cool. Something else you could talk about is the Doppler effect. So in the Doppler effect, recall that had to do with the an increase or decrease in the frequency of sound, light, or other waves as you have a source and an observer move toward or away from each other. And what happens is it causes a sudden change in pitch that was noticeable, for example, in the passing siren, as well as redshift, which is seen by astronomers. We could also talk about waves. We can compare or talk about just the equation for waves with the relationship between frequency and velocity. With waves, we could talk about how that relates to the electromagnetic spectrum and different colors we see as well. In chemistry, we could also, again, continue that discussion of the electromagnetic spectrum, the different types of light, so infrared, ultraviolet would be of importance as it relates to light that we see and how we measure light. We could also talk about the different spectra types, so emission spectra versus absorption spectra, and how that could be used to look at the identity of elements in stars. We could also look at fusion reactions and what type of, or where do those fusion reactions happen, what type of stars and such. So earth science is one of those sciences where there's going to be lots of applications of astronomy. So first off, let's think about the solar system. So the solar system is this gravitationally bound system of the sun and objects that orbit it, either directly or indirectly. Of the objects that are orbiting the sun, we have these, the largest are the 8 planets, and then you have the remainder being smaller objects and dwarf planets and other solar system bodies. You could also talk about the Milky Way. So the Milky Way is the galaxy that contains our solar system. The name of the Milky Way is kind of interesting, and that it describes what does our galaxy look like when we look at it from Earth. We have this hazy band of light in the night sky formed from stars that can't really be distinguished with your naked eye. Next, you could talk about the sun. So the sun is the star at the center of our solar system. So kind of fun to get into. You could talk about it's like almost perfect sphere. You could talk about its internal convective motion. It generates this magnetic field via the dynamo process. You could talk about how it's an important source of energy for all life on Earth. You can get into the size of it, 1.39 million kilometers. Or you could say it's about 109 times the size of Earth. Like, you could get into the mass of it. You could do conversions with the metric system, things like that. Next, you could talk about the moons. So we know that moons are these natural satellites. They orbit planets and asteroids. There's more than 200 moons in our solar system, and most orbit the giant planets, with Saturn and Jupiter leading in the moon counts. But even smaller objects and Even Pluto has 5 moons in its orbit. You could talk about asteroids. So asteroids, you have these small rocky objects that orbit the sun. They orbit kind of like planets, but they're much smaller than planets. There are lots of asteroids in our solar system, so that's kind of interesting. And you could talk about the idea behind, well, where are most asteroids going to be located? They're in this asteroid belt. You could also talk about comets. Sometimes we, every now and again, we hear about a comet in the news, so I always like to talk about how, like, Comet Halley, when I was a kid, came up. But comets are interesting. They kind of look like snowballs of frozen gases, rock, and dust, and they orbit the sun. When they're frozen, they're like the size of a small town. So you could even look up the how large a comet would be and compare it to something that makes sense to the students. Like, okay, this would be the size of some town that may be near them, so that it creates some type of context for them. You could also talk about, so there are some schools that offer geology courses, so that would be interesting. You could just talk about what geology is, if not. And really, geology is going to deal with the Earth's physical structure and its substances, its history, the processes, what acts on Earth, etc. Celestial objects are also going to come up in the Earth science curriculum. Celestial object being anything that's located outside of the Earth's atmosphere, such as the moon, the sun, asteroids, planets, stars. So pretty much everything that we've been mentioning so far. And then stars are really interesting to kids, so that could be a very, another focus within the Earth science curriculum. Beginning with the fact that the nearest star to the Earth is the sun, and then maybe moving on to, well, what other stars are visible. Kids are always interested in learning specifically about, like, constellations and which star is which, the North Star, etc. So apps to figure out what kind of stars or constellations they see at night. That's always fascinating to kids, and something that's, again, real life to them. They could go outside and they could look at stars. Some of them own telescopes and things where they could see stars. So connecting those astronomy topics to Earth science definitely can help make them see the connection to their lives in science. In the biology curriculum, you could talk about the evolution of the solar system, the evolution of life in general, and how that relates to astronomy. You could also talk about habitable environments, like what environments are habitable in our solar system. And students love to talk about future life forms. They love to talk about, is life habitable on other planets, and things like that. Sometimes getting a little bit of sci-fi into, science fiction, like, do we believe in the aliens and things, or are there aliens or things living on other planets? So definitely something that would be interesting to them. Next, you could talk about the nature of science is a key reason to try to understand astronomy. Astronomy is interesting. You have, stellar examples of how models are going to change over time. So, for example, the heliocentric versus the geocentric model, and how sometimes observations can lead to giving us more informed scientific knowledge to change our models. And that's how science works. It changes over time. You could also talk about technological changes and how that helps inform what good models are. You could also have kids draw models throughout the different courses, because the importance of modeling and thinking about what these things look like is important. You should also incorporate, or could incorporate, technological advances and how that's shaped many of the things that we now know about astronomy. So we look at, well, many of the things you can't physically see. So as we developed telescopes, and as the telescopes became better and better, we were able to see and identify more information. We could also talk about space exploration and how far we've come with that, and how we know what we know about planets, and how do we measure things on other planets. So I think that whole piece of technology is interesting to many kids, and learning about how does that technology help us know what we know about the solar system and planets, etc. And I think the number one reason that students should learn or take astronomy is to help them become scientifically literate citizens. So the idea is that astronomy is so much ingrained in a part of our lives, it's physically around us all the time, that it's important that people are able to see things and observe things and understand what it means. So sometimes astronomy stuff seems weird, but it actually ends up being true. So like I had a student one time that was telling me that they didn't believe the black holes was actually a real thing. So it's providing students with evidence so that they could understand how do we know what we know based on the observations that scientists have done. Also things like radiation from the beginning of the universe. Some people have no idea about the Big Bang, or how do we come to have the solar system that we have today. And like I mentioned before, science fiction has become very popular, especially for the youth. So it's important that they know there's differences between, well, this is actually real and this is fiction. And lastly, I would encourage students to take astronomy courses so that they learn about the different career options that exist. Sometimes students think that an astronomer is just maybe somebody that looks at the planets, and they don't really know what they do. But it's actually a very diverse field. There are applications across numerous industries, ranging from aerospace, energy, medicine, industry. So there's a lot of different applications that it's important that you could tell students about, just so that they're at least aware of it. They also could get involved in a lot of different fields. Like maybe they like physics and they like astronomy, so they can go into, they could use the laws and applications of physics in astronomy. And sometimes they don't know that as a kid, and you could tell them, like, hey, there are different courses that you could take in college, or they're just not aware of that. So you as a teacher being able to tell them, or just at least plant the seed in their head, just to maybe get them excited about it. And also knowing that astronomers have many different skills and specialties. Like, it isn't somebody that's just sitting behind a telescope. There's different types of astronomy research that's done. They could be, it could be like an instrumental person, like the instrumentalist. They could be somebody who's an observationalist, theoretical astronomer. So it's not like one thing that classifies you as an astronomer. So I think getting kids excited about astronomy and telling them about all the career options, or not even all of them, but just giving them suggestions for these are some career options that you might be interested in, would be beneficial to them as they move forward in their college career.